Good morning, everyone. How are you all this morning? Are you recovered? You're recovered? You're tired? All right, we'll have a nice lesson this morning. And guess where we begin? Where we started our journey when we went on that trip. All right. When we all got in that boat and Dr. Leslie began to speak to us and informing us of all those wonderful things that we saw and all the knowledge we gained. He gave us so much. But I'd like to remind us what was the first thing that Dr. Leslie spoke about when we got into that boat. Yes.
He spoke about the brown water. It was because the river met with the ocean, then the water mixed, and then it turned brown.
Yes, he spoke about the brown water, the river meeting the sea, and there was the brown water. Do you remember what he called it? What term did he use? What did he say that brown water was all about? Come on, reflect back. That was the first thing Dr. Leslie spoke about. He told us about that, and then he told us that later as we moved on in the boat, the water was going to change. But he called that brown water, as so rightly said by Erwin, he called it a special name. He said it was?
River silting?
Yes, he called it silting. He said it was, the brown water was caused by silting, the river silting that had emptied now into the sea. You remember now? Okay, this morning, that's where we begin. Just like how our trip began, our lesson begins this morning. And when I heard it, I said, oh, very good, because it's exactly where we will begin on Saturday morning. River silting. From the brown water then, what do you think causes silting? What would cause silting to make that seawater become brown? Edwin?
I think after a strong storm or strong rain.
After a strong storm, rain, very good.
The water washes off the topsoil of the
It washes off the topsoil
and into the river, which
and
then
takes it to the river. Takes it to the river and then to the sea. It empties out into the sea. Very good, Edwin. Thank you very much. Okay, according to our definition here, river silting, removing the forest vegetation increases soil erosion. When the forest vegetation, we have been talking about the pine forest for a couple of weeks now. And vegetation would be all those trees that are cut down. It says that it increases soil erosion. So the silting is actually caused by erosion, like what Edwin explained it in a little bit more details. That soil is washed out into waterways when it rains, just like what Edwin shared just now, increasing the particulate matter in waterways. So it increases all those, you will hear the word sediments, all the sediments in the waterways. Today, our objectives would be, we're going to identify some major types of sediments this morning. Some you may know, you may have heard the names already, so some will be review and maybe you'll be learning some new names. We're going to observe the effects of siltation on water bodies. We're going to become aware that suspended sediments can be harmful. Suspended sediments will be those sediments that are dispersed, that are scattered and are wrong. And we're going to find out about sediment size and current velocity can affect the deposition. So the size of the sediment and the speed that it moves, how the force that it has to move, it will affect how it is deposited into the ocean or the water body. Right? So those are objectives this morning. Let's begin with silt and sediments. Those two terms will be used together. Silt and sediments refer to the fine-grained soil particles that form the beds of lakes, rivers, and streams. When we stand in a river, in any water body, we can feel those sediments under our feet. It's normally fine grain, which over a period of time, they're going to be changing, and we will be seeing that. But it actually settles there under the water. It is natural to find silt and sediment in water, so it is natural. But then there is that point where when it gets too much, when we have too much erosion, then that's where it becomes a harm and it affects the water body. Problems result when excess amounts. It says excess amounts, meaning that it's more than normal because it's natural, but then it becomes more than normal when this is introduced into the water. And this can be harmful and will affect water quality and fish habitat. What do you think is meant by it will affect water quality? What do you understand about water quality? It will affect water quality. Let's go to Edwin first.
When the water filtration system, they have to filter the water in order to get it at a clear quality. They have to filter it over and over. So the more dirtier the water is that they collect, the more they have to filter it, and the more they have to purify it or try to disinfect it.
Okay. It affects water quality. You used the word clear just now when you said other things that relates to the effect. Who else would like to add to what is water quality? It affects the water quality. What exactly happens to the water then if it affects the water quality? What do you think would happen to the water? How is it affected? How did we see it affected on that trip? When we got into the boat, what was the first effect? There was silt in the water. What was the first effect of that water? Come on, it was mentioned. We just spoke about it. Describe what the water looked like. It was, was it its natural color? What color was it? It was brown. So that was the first effect. That's the first effect. You will see that water looking brown. Many times we give another name to the water. When we see the water flowing down the stream, flowing down, and we look at the river, we see the color changes, especially when after there's a heavy rain or and flood follows that. We would say that the water is dirty. We would say that it's flooded, isn't that so? Yes, but actually that's what we mean by silt. That siltation occurring there. Do we understand that? So that's the first effect. It changes the color of the water. It looks muddy. And we will talk a little bit more about this. And fish habitat. Would you like to take a guess on how you think it would affect the fish in the water? Go ahead, Erwin.
Like with the brown water by Marina, I don't think any fish were living in there, so the water drove them back more into the sea.
Most definitely, the water they would want to move from out of that water, because naturally it will affect something, particularly for them. It would affect their breeding, right? It would affect their breeding, and it would not give them the right type of food to feed on. So it would affect their food and their breeding. So the fish would want to move from there. Okay, here's a lovely river, all Belize. This is the Belize River. Notice there, do we see any sediments in there? Do you think at this time it's being affected by silt? Does it look like it's affected by silt? silt? No, not there. It's a normal day. Seems to be a very sunny day, and that's what our rivers or streams usually looks like in Belize. How does rivers flow? How do rivers flow? Where do they usually flow from? Erwin?
Well, in Belize, they usually come from the Maya Mountains.
From the Maya Mountains. They come from highlands. And this is what the picture is showing. It is coming down from a highland, flowing down. And of course, it continues to flow. They connect somewhere, and they continue until the rivers empty into the sea. Dr. Leslie also mentioned 2 rivers that emptied into that seawater where we were sitting in that boat. Do you remember the names of those 2 rivers that he mentioned? The 2 rivers that emptied right there, that had that silt, that caused that siltation. You remember those 2 names? We were sitting in that boat right there where that water emptied. And there was a lot of silt in it. You remember the name?
The Belize River.
The Belize River was one. Very good.
I think the New River.
No, thank you. Good try. The New River would be up north. There was another one beginning with S. Kyle?
The Siboon River.
The Siboon River. Thank you. Quite correct. So where we were sitting and where we started our journey, it was the Belize River and the Siboon River that emptied right there in the mouth of the sea, and we were in that boat ready for our travel, and there we saw that siltation. All right? I'd like you to take jars. I'd like you to open them and carefully kindly empty your 3 cups. I'll call these sediments into your jar. Try to do it as lightly because these they're kind of thin. And I have here this. Can you tell me the name of the very dark one? Yes, Kyle?
Black soil.
Black soil. Yes, we would call it topsoil, and that name came up a little earlier. So you have your black soil, your topsoil. You have this yellow looking one, all sand, but it's a bit hard. Can you give me the name of this one? Begins with CL. Go ahead.
Clay.
It's clay. And what do we call this one with the stones and the sand? Steven.
Gravel.
It's gravel. All right? Gravel. Okay, so take your 3 and you can empty them into your bottle. And then you will pour the water, but gently pour the water because you want the water only about an inch above it. Don't pour all. Just pour about an inch above the sand. Put it closer to you and do your thing. Okay. Pour your water in there. Pour enough. Pour some more. That's about that. About that. A little bit more. You're using about half of your mug of water then. Okay. Kindly close it a little bit more, Ainsworth, please. Let's see yours. A little. Yours look okay. A little bit more. Little more. Okay, thank you. All right. Kindly close it tightly. Very tight. And you take the top, make sure that it's tight. Take the top, take the bottom, and shake it thoroughly. Hold it on the sideways and shake it. Shake it properly. Shake it, shake it, shake it. Have some fun. Play with some mud and water. Isn't that nice to play with some mud and water? Good, have some fun. All right, learning comes with fun. Now you can take it now and kindly put it down. Put it back on the brown paper. Let it rest there. Or it needs to stay flat, so you can just put it on the table, Erwin. Okay. Now, let's make predictions. You place 3 types of soils. In this morning, I'm calling them sediments, into your bottle, into your jar, and you add water to that and you shook it. Isn't that so? Now, let's predict when that all settles. Tell me, make some predictions. What are we going to see? Let's get the first hand up. Make some predictions. We can be right, we can be wrong, and that is quite fine. Edwin.
I think the gravel and the clay will sink down to the bottom of the
Okay, let's
jar.
take that one first. Edwin says that the gravel will sink. How many of you agree with that? Okay, what? Next prediction. Remember, predicting allows us to be right or to be wrong. Next prediction. What else is going to happen? Go ahead, Ainsworth.
That the water is going to take all the sand off the rocks.
The water will take all the sand off the rocks.
And make it dirtier.
Make it dirtier. All right. That's a good one too. Daisy is ready now.
Dirt stay at the top.
The dirt will stay at the top. What do you mean? What do you mean by dirt?
Dirt that had the topsoil had is at
The
top of the
topsoil will stay at the top. The topsoil will be to the top. How many of you agree with that? Good. Referring to the soil that you place there as silt. Let's pretend that this is the river, that it all flowed down into the stream. All right? Now, what type of force? If we look at the soil and all of this was coming down the stream into the river, going into the sea, what would take topsoil? Just imagine different types of rain on different rain occurring, hard rain or maybe just a little shower. What kind of erosion would cause the soil to move, like the stones, or the topsoil to move? Go ahead.
When it rains, the current might get harder, but it will move faster.
It will move faster. Which one would need faster pressure to move, if we should call it that? Which one would reach down the stream first, or which one would move from the vegetation first? Move off the land first. Which one would move first in the erosion?
The black soil.
The black soil. Yes, the black soil. Would they all be eroded? Do you think all can be moved by erosion, or only black soil can be moved? Do you think all that we said here that I call silt, do you think all of this will move, will be eroded? Or it's just topsoil that erodes?
I think the gravel and the clay would move, but it wouldn't move far.
It won't move far. Is that what you said? That's a good prediction. All right? Okay, as we go along, we'll be answering these questions, and then we'll see what our prediction. We'll see about the predictions that we made. Now, I did this one yesterday, and I tried not to move it. I think I was moving it. This was the, okay, can you see this? Notice what is happening here. You might have to look at the bottom. Just pass it around a bit. Let's see at the end of the lesson if yours would be looking like this. We'll see different settlement of the soil in yours. Try not to shake it. Just tell us what you see, Daisy. Tell us what you see. Anything you see, just say just describe what you're seeing there.
All the sediments are mixed together,
They're
and
mixed, okay.
some of the gravels at the bottom.
Some of the what? Some of the gravel is at the bottom, okay.
And the clay too.
The clay. Is the clay a little higher than the other soil? Yes, it is.
It is.
And where is the black dirt, the topsoil?
It's at the top.
It's at the top.
The top.
Okay. And then we see some other things that sometimes we call dirt settling at the top. Isn't that so? There's another name for all that topsoil and that dirt. What do we call it? Begins with an H. Cal? Humus. Okay. Very important to soil, very important to vegetation, but easily eroded. That's the first one that will come down in that stream of the land when the trees are torn down. I'll give you a minute more to move around. It's kind of shaking up. When I look at yours, I see some already settled, even better than that one in the bottle there. So in a short while, you'll be able to see yours better than what this one is showing. Thank you. Let's continue. Now, most of the time, you find that erosion occurs due to clearing of forests. Do you understand what I mean by clearing of forests? What does the picture here show? It shows farming. It shows farming. What had to be done here for the farmer to do the farming? Deforestation. Yes. Notice that it's a slope. Notice that it's done on a slope, and most of the time when we have erosion, it's because of clearing being done on slopes. All right? So this is an example of the clearing of a forest on slopes that causes erosion. This again, it doesn't look like the slope, but it is. It's another slope. Here again, where do you think all of these sediments, where do you think they will go? Eventually.
They will eventually end up in the streams and rivers?
Yes, they will eventually end up in streams and rivers and later to the sea. All right? Recently, if you were paying attention to what was happening in Belize City, there's a part of Belize City that was being cleared. And the environmental group, the organization, got involved, and they were very bitter about the action that was done. But apparently, this company did get some kind of permit to do the clearing. And then later, they realized that it was not the best place that the clearing was done. It would have caused a lot of erosion, and it was going to affect animal habitats. So now, this company now is in negotiation, and they have promised that they will be doing something to make the situation better. And they have apologized. But what happens? The damage has already been done. Okay? But this will eventually end up right where we would not want it to go. All right? So here we have deforestation. Erosion. We're speaking about erosion. And what is erosion? It is the movement of sediments from one place to another by water, wind, or natural forces. Natural forces would be, what would be a natural force to move sediments or to remove sediments from land? Go ahead.
Hurricane, earthquakes, and
Hurricanes, simple rain would do that, okay? Hard showers. Erosion happens when sediments are carried in a river, the river lows and deposited elsewhere. So as we found out on Thursday, though it was deposited into the sea. All right? Types of sediments. Some of the sediments that we need to learn about are Mainly, we have the first one called conglomerate. We have the other one, sandstone. We have shale, we have limestone, and we have dolomite. Those are 5 types of sediments. 5 main types of sediments that somehow or the other would be relieved into the sea, or it will end up in the river, some other water body, and the sea, right? The first type of sediment here we call the conglomerate. It is usually formed in places with fast moving water. So this type of soil, it says, would come down the stream with fast moving, with fast pressure. Finding conglomerate with large particles often suggests that when they were formed, there were mountains nearby. So it's going to be all those types of soil that you'll find around the mountain that will eventually form. It is sediments, and they actually, after a while, they form stones, right? Conglomerate actually means variety. So it's a variety of soil that accumulates together. There are usually large and small particles intermingled within the rock. Let's look at one. If you notice here, this is a conglomerate stone. This is the type of soil you will get where you will have big pieces and small pieces together. You have a variety. Let's say the word together, conglomerate. Say it for me. Conglomerate. That's one type of soil, and that's a conglomerate rock. Okay? Eventually, they become rocks over a period of time. Then we have the sandstone. It forms where the flow is slower. So the conglomerate, we heard that it forms from fast moving water, and now we hear that the sandstone flow is, this forms from slower water. It doesn't need fast water to go down to move as sediment. Sand grains bounce down streams without much difficulty. So this is easy to erode. That's what it's saying. Easy to erode, easy to move away. Even slow moving streams can carry vast amounts of sand. So it doesn't take a lot to move this type of soil down. Okay? Erosion doesn't take a lot. And we know this is what the sandstone, what the sediments look like. All right? If you notice it is much finer. It is much more dense. A lot of it, but it's finer, so it's easier to flow down, easier to move. All right? The sediment erodes easier. And then we have shale. Actually, shale is the silt. It's that is what makes the water look so muddy. It is made from silt in the water. Of course, it will take a long time to really become a stone, but the particles are so small that they can stay suspended in water for a while, even after the river or stream has stopped flowing. So suspended, that means that they're down there, and the particles are there. They have not come together to form any rock or anything. It's just there, and it stays right there, all dispersed out. Okay? Silt gradually settles to the bottom, but this one will stay for a long time, and it will cause a lot of silt, because this is actually the dirt, the silt. The picture here can be interpreted to be there was a massive disaster or something, and that is what was left after, from the erosion, and after all the water went down. That would be what was left. 1978, I had the experience of Greta. Maybe you all were not around at that time, right? Definitely not. I was a high school student, so you know it's long. And we lived in a very low house. And the Hurricane Greta did a lot of damage in Belize City. And I remember, because our house was a bungalow, when we went home, the silt, all the erosion that occurred during that hurricane because of all the wind and the rain, and all of the silt was washed it went down into the streams, down into the sea, and then it came back. And that came back on land. And in our house, the bed was silt. The cups and the plates turned over that had silt on it. The clothes, everything you touched in the house had silt. It was mud. And I remember my mother had to get the fire engine came around and it washed out all our houses because they had to get rid of it because of the stench and because it was going to get hard, and then we would have a very hard time getting rid of it. And so a lot of things were spoiled. Could you imagine you go and you touch your bed and it's mud and it's silt? It's very, 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 you know, when you step into, sometimes when you step into a body of water and you feel that soft soil under your feet, well, that was what it felt because you had to move around, and that was what the hurricane brought. So it eroded, there was erosion, and then it came back on the land. And so this definitely reminds me of what had occurred in 1978 and my experience that I had. Okay, so that silt, that one particularly is shale, and it's actually made, the stones there, the rocks there are formed from the silt, from the mud. Okay, that would be more of your topsoil there. All right, now the limestone. Normally limestone is not washed into the sea, all right, or into the body of water. Limestone will happen in the sea, where you have all the shells. If you notice here, there's a lot of animal shells, and when the animals die and these they erode, they form limestone. So this is not one that is usually washed into the sea, but it's a sediment in the water body also. Okay, and limestone is mainly calcium carbonate. It says that it's made from the infinity of microscopic skeletons that rain down on the sea floor. For example, shells of larger organisms, shells of sea animals that would create that limestone. Then we have another one. It's called dolomite. Dolomite is similar to limestone, except it forms in the oceans in places that have magnesium dissolved in water. So magnesium would be in the water. That's another natural element there, and it often forms from limestone as the calcium in calcite is partially replaced by magnesium. So you notice that the limestone, this is a brighter one. It looks whiter and it's brighter. So the limestone then can go to another stage where it becomes dolomite. It's also sediments in water bodies. Okay, so we have can we review them? The types of sediments that we should get familiar with. We said they're the glomerate, there's the sandstone, there's shale, there's limestone, and there's dolomite. Now, types of erosion. We have water erosion, we have soil erosion, stream erosion, splash erosion, sheet erosion, and rill erosion. Have you ever heard these names before? Which one would you be familiar with? Soil erosion. Any other? Water erosion. Earlier I showed you a picture that actually was water erosion. You remember which picture that would have been? The waterfall. That is a water erosion. Okay, that's a natural occurrence. Do you think sediments come down while that water keeps flowing? Yes, it does. Okay, so let's find out about erosions then. Soil erosion. Notice what is happening there. Earlier, it was said that soil, for example, like the sand, doesn't need a lot of force to bring it down. Okay? That's some erosion taking place right there. That's called soil erosion. It's mainly caused by humans when natural vegetation is formed, is from the steeper slopes that are removed. So from the this would be coming from a steeper slope, and it's coming down, and you notice it doesn't need a whole lot to bring it down, because sand, those kind of soil, easily move down. Terraces should be done to give longer and slower runoffs for minimal force. What does it mean by terraces should be done? What would be terraces? What do you think terraces are? Okay. Do you see how plants are done in rows? Okay. What the farmer needs to do is to those are terraces when they dig in rows, so that you don't have that one force coming down. So they would dig in rows and they would plant in rows, and it helps from erosion, because then you would have the trees being spaced apart, okay? Spaced out. So terraces are recommended to help with soil erosion. We also have the valley and stream erosion. Valleys change and grow over millions of years. So this one also many times is a natural occurrence. Okay, valleys that comes between the mountains, they change and they grow over many years, and erosion causes the changes most of the time. Stream erosion digs them deeper and wider. So you have this, maybe some years ago, was a very thin stream. And over the years, because of the continuous flowing, the continuous force of flowing caused by weather and everything, it gets wider and it gets longer. And it says that it also makes them longer by eating farther and farther into the uplands where they begin. So that stream goes up, 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 almost to the mountain. All right? Where the slope flattens out, the stream slows. And then the water can't carry as much sediment and deposit. So where you find that it's flatter, you will not have the stream flowing that fast. It's going to be slower. So it will take, what will it take with it mostly? It's going to take soil, rock. Which one will go first? The soil would go. Yes, the soil would be deposited more than the rocks. The sediment builds up and changes the way the stream flow. So streams actually change their the way they change to suit how the erosion is taking place. Okay? This is what we call sheet erosion. Would someone like to explain what is happening in this sheet erosion? This one, yes, go ahead, Edwin. What would have caused all that water to be flowing?
A flood that has spread all across the farmland.
A flood that has occurred all across the farmland. So there must have been a storm or some very heavy rain. All right, describe how that water is flowing. Why do you think it's called sheet erosion?
It's spread out.
It's spread out?
It's not in streams, it's spread out. So it's kind of like a sheet of water over the
farmland. We like to use that word sheet. Okay, sheet of water, sheet of rain. So you notice it's pouring rapidly. So there must have been a very hard shower. And here we have now, we can see that that's actually erosion taking place, and it's called sheet erosion. It says it is the detachment of soil particles by raindrops impact. The impact of the rain and removal down slope by water flowing over land as sheets. So it's just continuously, right? That's sheet erosion. We have splash erosion. Look at that picture. What's happening there? What does that picture show us? Go ahead, Ainsworth.
Raindrop coming down and then hit the soil.
Hit the soil. In our normal everyday life, we see erosion sometimes occurring right around where we're walking and moving, where do we see splash erosion happening?
Usually when it rains, I go outside my house, and because we have like a zinc veranda. When the water runs down the zinc, it hits the ground, and then a lot of little holes stay.
A lot of little holes.
Yeah.
In Belize City, we have a lot of those where we walk. What are those, Kyle?
Potholes.
Potholes. So when we see the potholes, we'll say splash erosion. Okay? So even on the streets, we get some type, where we walk, when we get those, sometimes the street was nicely covered. And as that heavy rain came, you see all the little dugouts, and those are actually from the splashes of the rain. You can imagine, right? So we have splash erosion there, right? Let's continue. There's another picture here of splash erosion. This one is a bigger effect now, isn't that so? Okay, here we have now the water coming from definitely high, and then you imagine all of those things there, the splash happening in there, and other erosion would happen where those would come down. So you'll have soil erosion too, isn't that so? All right, so that is showing you some splash erosion where the water is, the rain is beating into the stream there. All right, rill functions as sediment source and sediment delivery. So it is the source. It creates the sediments and it delivers the sediments. Rills are small streams. If you notice here, it looks like where those are coming down, they will form small, you see them there? Normally it breaks the ground away. It detaches, and so you'll have all of those there, those small ones, and they will just fall small streams, bring in a lot of soil. That's why it says that it's sediment delivery. It creates a lot of sediment. Okay, so it's a sediment source and sediment delivery erosion delivery system for erosions on hilltops. The sediment load has a large influence on soil detachment rates in rills. So this would create a lot of sediment. Okay, so those were all types of erosion. Let's review them. Let me hear the name. Don't go back yet, sir. Let's hear the name of these erosions that we learned about. W, I'll say W and you give me. W, Stephen.
Water erosion.
Thank you. S, Erwin.
Erosion.
Splash. S again.
Stream
Stream
erosion.
erosion. Tell me the others then. There's another S. Kyle?
Soil erosion.
Soil erosion. There's an R.
Erosion.
Rill erosion. Did we leave any out? Sheet erosion. Did we say that? Sheet erosion. All right. Let's call them together. Let's go back and call them together. Water erosion. Help me. Soil erosion, stream erosion, splash erosion, sheet erosion, and rill erosion. Would any of you like to just tell about one? Explain one of them, just one. A volunteer? Maybe a girl I haven't heard from? Daisy, would you want to explain one?
Splash erosion.
Splash erosion.
Splash erosion is when the rain comes down hard and then it forms some little potholes.
Okay, it
Like-
beats the soil.
And then they have it digs the soil and
Okay.
that makes some holes in the
Okay,
ground.
makes holes in the on the land. All right. Thank you. Let's continue then. Well, of course, if you have all these erosions, then you will have effects of siltation because you have the silt and the sediments that gather and move because of erosion. Sediments entering a water body will negatively impact water quality and quantity. We come back to this word quality again and not quantity. We said that it negatively impacts water quality. Why? That was discussed before. Why does it impact the water quality? You want to repeat what you had said, Edwin, on water quality?
When the water is filled up with silt and different sediments, it's dirty and it doesn't look clear.
Dirty. It's not clear. Good. What about the quantity? What do we mean by it impacts the water quantity? When we talk about quantity, what are we talking about? Begin with A. The amount. How does it impact the amount of water in that water body? Do you think it impacts the water, the amount of water?
I think at a large scale it would be more soil than water, so I think it would affect.
It would be more soil than water. Very good. So, therefore, it is impacting
the quantity
of water. Look at this. Let's continue. It says it reduced water storage capacity. Like what Edwin says, where there's water, if you have the siltation, you have the sediment, then it takes that space. Can severely limit the use of river for drinking water storage and irrigation water. But let's look at what I have here. Did you know, we're looking at water reduction. Reduction of water storage capacity. Did you know that 1 cubic yard of sediment, you heard the word cubic yard? Okay. When your parents go to buy sand and gravel to do the cement work, they will buy it by cubic yard. It says 1 cubic yard of sediment displaces 202 gallons of water. So if you have this amount of sediment in the water, it means that this water here, the gallons of water that we would call good water to drink, to use, actually it displaces it. So it takes that space. So that's the reason why we know that sediments will be there, but we don't want too much or we don't want extra there. 1 acre of 1 foot of sediment. If you have an acre of that water body and you have sediment at 1 foot high, it says it removes 326,000 gallons of water storage capacity from the lake or the river. That's talking about the water quantity. Alright? So it severely limits the use of river for drinking water storage. And we know that the farmers, they need it for irrigation too. Right? That's why we don't need the sediments. There are a large amount of sediments in our water. Go ahead. Other effects. It reduces recreational use. Why? This one is to your advantage or disadvantage. Let me hear from Irma. The recreation, it reduces recreational use. What would be a recreational use of a water body? What do we mean by recreational use? You want to give it to somebody else? Okay, I'll come back then. Go ahead, Erwin.
And saying it reduces the recreational use, it means that like the water parks, they just use it for pleasure.
For pleasure, yes. To bathe, go and get for a nice swim, okay? To ride in your boat, take a boat ride down the stream. So if you have sediments there, then you have lesser water to do all of that. That's the reason why you would go some places in that water body and then you find that your boat just stopped because of all the sediments loaded there. It can't even move or pass. Okay? So that's siltation, river siltation. It stimulates noxious aquatic weed and algae growth. So harmful weed and algae will grow. It says that stimulates aquatic weed and algae growth. Because sedimentation is the result of soil erosion in watershed, nutrients of nitrogen and phosphorus is often transported on the soil, particles into the water. So it gets a type of nutrient that it doesn't need, okay? This nutrient influx in shallow water creates harmful aquatic growth. So it is saying that when you have the nutrient of nitrogen and phosphorus in that water, then you will have some effect of those weeds and those algae growth in the water. It degrades habitat for fish population also. For example, we were told about the mangroves and how that area is used for all the spawning of the aquatic animals and where they would go and feed. Could you imagine if that siltation would continue and let's say that we have a serious problem of erosion in Belize that would reach the mangroves, then all the little fish would not have a place to feed or for the young ones to occur. All right? So it says that it degrades the habitat, interfering with oxygen uptake by plankton by having suspended particles limit light penetration. So where we have those microorganisms, you will find that the mud, that siltation that is there, it's going to affect the photosynthesis. It's going to affect the organisms that these animals feed on. They won't be getting the oxygen the way they should because the water is contaminated. All right? So we see how river silting and we see what erosion can do. It's very, very dangerous. Some more effects. It degrades the appearance of the lake. They said that when like for example, people living near to the river, they have these beautiful houses, there's a beautiful scenery. Now, it's not the same when that river starts to flood and there's a lot of siltation. It makes the place rather ugly, very unattractive. Isn't that so? So even degrades the appearance of that area. It wouldn't look, if we had siltation in that river, that past picture that we have, it wouldn't look like that. It would really not be a beautiful scenery. It reduces waterfront property value. So if you live in an area where there's a water body and then you have siltation starting to affect that water body, then even your property that you have beside that water body devalues. If you want to sell it, people might say, oh, that's not the best place. I can't get my fish. I can't go and bathe and recreate there. It's not going to be nice for me. So even property value along these areas are affected. Suspended sediments block sunlight and threaten living organisms such as phytoplankton, oysters, and other small aquatic animals that are food for fish. The phytoplanktons are the small plants, the microscopic plants that the fish they feed on, and the oysters and all those things there are being affected when you have suspended sediments in the water body. Okay? It says here that when it degrades habitat, it will create muddy water. It covers spawning areas like what was said just now. It interferes with fish breeding. That was said by you, and reduces the planktons, which would be some of what the aquatic animals need. Okay. Now here are some pictures that shows erosion and the effect of erosion. Let's call the first one here picture 1. Would anyone like to describe what's happening here and what is the effect here? Edwin?
In that picture, you can see the waterway or the river.
Yes.
It's very dirty because of the sediment that
Yes.
has run into it from the erosion. And
Which effect would you relate this to? From what we said just now, which one of those effects would this be related to?
Soil erosion.
What were some that we said? We said habitat, property value. What else did we say? Which one would you relate that to?
The habitats for fishes, because fishes can't live in that dirty water.
Definitely they not harmful for the aquatic
And since
animals.
it's depositing into the sea,
Depositing
it also
into the
affects
sea.
it stimulates aquatic weed, so it can't grow.
Very
there.
good. Very good. What about the second picture? Definitely there's an effect showing here. Who would like to take on this one? What effect is here? What I asked a question about, did you know? What's the effect here? What is it taking away? Kyle?
It's being eroded into the water.
Yes. And so what is it taking away from the water body? Q?
The quantity,
Quantity and?
quality.
And quality. Quantity and quality. Because quantity, you notice that the silt is very high, the sediment is very high. So it's taking away some of the water body, and eventually it's going to be affecting the entire water body if it continues to if the erosion continues and that continues to build up. Isn't that so? So it's quantity and quality. And if you notice too, there's a little house behind there. So it is affecting property value. That little house looks like it would want to, it's in the water now, it's affecting property value. Isn't that so? Yes, it is affecting property value. All right? Go ahead, sir. Here again, pine tree or pine trees. Effects here. What's the effect here? Go ahead.
The hillside can collapse.
Yes, you can have erosion. You can have a soil erosion there. Isn't that so? All right, go ahead.
Animals could lose their habitats since
Habitats.
they were living.
Affects habitats. Very good. And our second picture there.
The trees and plants right there.
Isn't it taken away?
Yes.
Could be it's taking away animal habitat. What else would it be taking away? QU? Is it taking away quantity of water? Remember we heard about the things growing, algae and weeds growing. Okay, it's taking away quality and quantity. All right. If you notice what's happening here, it could be that the body of water is getting smaller because of all this erosion. Would you agree with me or you don't agree with me? We're making some assumptions, okay? We're making some assumptions. Do you agree with those, or would you say that can happen? Yes. Okay, let's continue. Here again, okay? Who would like to take on this one? This again is sedimentation. This is river silting happening right here. River silting. Is this something that we've seen before? I know it was taken from the air, but is this for real? Yes, it is. Okay. Quality, quantity, property value, all the effects. Animal habitats, affecting the food for the small aquatic animals. All of that. Now the other picture is, shows that that's the buildup of sediments down there, and that is what it would have looked like first. Under a microscope, you may hardly see the sediments. Later, as it builds up and it continues to build up, this is what it says that it would be. It just shows you that it gets thicker and it accumulates more and more. Right? Mitigation. Do you remember what we said mitigation means? Go. Mitigation? To make something less severe or to make something better. Good. What can we do for better management to prevent erosion? What can we do? Edwin, then Erwin. We'll hear from both of you.
Do better planting techniques.
Better planting techniques.
Sure.
Good.
Plant trees along the shores of the Rivers and seas.
Plant more trees along the shores and the rivers. Very good. All right, those are two answers. Very good, very appropriate. There is need to protect shoreline vegetation. How? How? Let's continue. 1. Can someone would like to read the first one? Just up to the word rivers. Go ahead, Kyle.
Avoid introducing silt and sediment into lakes and rivers.
Okay, remember it's there already, but we must avoid introducing more. We must avoid getting more into the lakes and into the rivers. Note, it is important to avoid the introduction of these materials into the water. Planning and designing work projects with care and implementing environmentally friendly practices will protect fish and fish habitats. Now, all along for weeks, we've been talking about environmental friendly practices. Edwin just said we plant more trees. Would you take a guess what if some company or someone is going to be doing some kind of work project, maybe building, and it's close to a water stream? What would be one friendly practice that company may want to consider? What would be a practice that you want them to consider? Just think about it.
They should plant very thick and rooted plants along the edge of the water source, so that whenever it rains and the water pours into the river or the sea, it isn't the full effect of what it would be if
so
the
you're
trees
saying
weren't.
even before they would begin that building project, they would start to protect that area by going first and start to plant the trees. Start to plant to build up that area and strengthen it. Like a wall.
Preventing
Okay? All right? That's a good thought. Anybody else? What would be another practice? What else do you think they would need to do? Do you think they need to do some kind of investigation? Type of soil? Some soil test? Do you think they need permission? They need to do proper planning, right? They need some permit, they need permission, they need to know what type of materials they're using by that water body. And that has happened a lot in Belize. For example, where we were taken by the mangroves, there was a big discussion, a big argument, because there was a company who were offered the go-ahead. They were given permission, and if I can remember, they were going to be building around the mangroves, and the villagers, the people from St. George's Key, were on the news, and they stood up and they said it will not happen. What's going to happen to the mangroves? We take San Pedro, a lot of the mangroves have been cut down for building purposes, to expand because of the population and because of all the businesses being set up there. Okay, so first of all, they have to do proper planning and testing to see if and to see what effect that will have before they take down those trees or get that place ready for a working project. Right? 2. Can someone read number 2? Let's have Irma read number 2.
Protect shoreline vegetation.
Thank you. So Edwin was ahead. Edwin said start to protect the shoreline. It says note, disturbance of vegetation often results in erosion of the exposed soils. If shoreline vegetation is disturbed, like what happened in Belize City too, ensure sediment and erosion control measures of silt curtains. So they have to put some kind of block, which is called a silt curtain. And I think that was what Edwin was referring to also. silt curtains are in place to prevent silt entering the water. So there has to be some kind of coverage, some kind of block there that is placed that will enable that the silt to, the soil to stay where it is rather than flowing down. Okay? Number 3. Daisy, can you read number 3?
Use clean materials.
Use clean materials, as simple as that. Ensure all equipment and material going into the water are clean and free of fine particles. So if they are dredging or if they're doing certain things near to the water body, they don't want to be putting dirt in there, or they do, okay, because that itself will be causing the siltation. And number 4, can I have Yemi?
Protect water quality.
Protect water quality. If an activity exposes soil to cause silt and soil sedimentation into a water body, then we must set up a silt screen or fence in the work area. Have you ever gone to one of these places like San Pedro and see when they're going to build that they actually set up an area around to hold in all of the materials? Have you ever seen that? Anybody has seen that? Or anywhere close to a water body? Okay, so the first thing they have to do is set up that silt screen or that fence in that working area. Many people don't do that. It doesn't matter to them, but it matters to us. Get detailed advice on environmentally friendly practices. And that company that came to Belize City and started to, despite they came for good purposes, their choice was bad. What they did was wrong. And after it was done, then the damage was done, then it was identified as a damage too, that would cause erosion. And here what it says that many times doesn't happen in Belize. It says approval and permits should be granted first before working around water. Why? Because the easiest thing to happen is sediments to go into that water, change the water, change our lives, change the animal habitats of the water. Why? Disturbance of shoreline vegetation results in erosion of the exposed soil. So it's simple. You have to protect the soil, because it will cause, if you don't protect it, then it's going to disturb the shoreline vegetation, which result in erosion. As simple as that. It's going to disturb the shoreline vegetation, and the result of that is erosion. And we learned about 5 different types that can occur. Okay? Any question? Today, we learned about types of erosion, types of sediments, some causes of erosion, some simple but very important things that people should do, that it is important to, for us to maintain and take care of our vegetation or shorelines. And all of it is because, like we saw Thursday morning, we had a little experience of siltation. We saw the water actually looking different from what we would want it to be. And so erosion can occur, which is very, very dangerous, and it has some great effect. And if it affects our water body, then it is affecting us also. Right? Now there's some group work here. There's 10 of you, and there's 6 here. Name 3 types of erosion. Explain them in a very simple way. Which is denser, gravel or sand? Explain. How can humus be responsible for causing siltation of rivers? And we're talking about the topsoil that you all were able to give a little about. Explain. Explain how sediments can reduce water quality. We spoke about water quality, or you heard about water quality and water quantity. Explain how sediments can reduce water. What do suspended sediments in water bodies do to aquatic animals? What does it do when you have these sediments in the water? All the siltation, what does it do to the animals in the water? What can be done to prevent erosion from causing the disturbance of water quality and fish habitat? Okay, we'll take 1, 3. We'll take 1, 3, 4, 5, and 6. 1, you better put up your hand quick. 1, Daisy. 2, Erwin. 3, Kyle. 4. No, your group did it. 4. All right. Ainsworth. 5 will be which 2 persons? Okay, let's try it again. Oh, no. I said we're not going to do 2. We'll do 2 together. Daisy get 1. So who was after? Who was 2? Which 2 persons would be 2? Okay, you get 3. And then the 3, who has 3? You get 4. 5, Ainsworth, and 6, Irma and her partner. Okay, kind of take the paper, discuss and write a little about, it doesn't have to be anything long. Okay, look at the question and try to explain the question in a short, meaningful way. But before you write, discuss a little. Okay? If you need me, I'm here. 1, 3, 4, 5, and 6. I'm going to ask you to read your question and then give the answer, okay? Go ahead, answer.
The suspended sediments will fish not be able to breathe with suspended sediments in the water, and they will not have food to eat, and the plants will be harmful to them.
Plants will become harmful for the fish, okay? Thank you very much. Okay, next group. Give us, identify the question you're giving.
We are doing number 4, explain how sediments can reduce water quality.
Thank you.
When erosion takes place, it runs sediments into the water, causing the water to become very dirty and unattractive. Therefore, it reduces the quality of the water.
Very dirty and unattractive.
This diagram could practically explain what he means. When it's raining very hard and there's some type of erosion, the silt water would run into the seas or river. It would create a harmful environment for seaweed, which would kill the seaweed or cause it to reduce in growth. No fishes would want to live there because they can't survive there because of all the silt and dirt around. And this other side is a very healthy water source where fishes can live. The seaweed is green and healthy. The soil is not all around. It's settled down where it doesn't disturb the animals very much.
Okay, thank you. Okay, let's hear from Irma's group.
We are doing number 6.
A little louder, please. Number 6.
What can be done to prevent erosion from causing the disturbance of water quality and fish habitat?
What can be done?
Planting more trees in this in the shoreline, putting walls wherever erosion will occur.
Okay, planting more trees on the shoreline and putting up walls for work purposes. Okay, thank you. Anna's group.
We're doing number 1.
Number 1.
Name 3 types of erosion. Explain them. Splash erosion, when strong water drops fall and digs out the soil, forming potholes.
Okay.
The other one is soil erosion, is the wash away of topsoil into the bodies of water. And the other one is water erosion, is when water comes down from mountains or waterfall.
Okay, bring sediments down with it. All right, thank you. And then we hear now from Erwin and Stephen. And your number is?
Number 3.
Number 3.
How can humus be responsible for causing siltation of river? Explain. It's responsible for most of the siltation in rivers because it's the easiest to be eroded. So hence, it is responsible for the first part of water siltation, and it is very visible on the surface of the water.
Very good, very good. It is responsible for most of the siltation. It's very visible. Thank you. All right. Which is denser? Can you raise your hand? Which is denser? Gravel or sand? Okay. Let's see if I see a new hand. Okay. Go ahead, Stephen.
Sand.
Sand is denser. Which one would cause more erosion? Which one is easier to erode? Go ahead.
Sand, because it is more lighter.
It's lighter, so it only needs slow force. It doesn't have to have any great force, strong force to bring it down. While the gravel would have some rocks in it that will need more a heavier rain or storm to cause erosion. All right. Any final word? Anybody wants to say anything? Would you like now to comment on that jar in front of you? It's quite clear. Could you tell me where you're seeing the stones themselves? Go ahead, Erwin. Where are the stones?
Some of them are in the center, and then they have a layer of sand or clay on top of the stones.
When you say center, at the top of the water?
Well, in the middle between the bottom and the top.
Okay. Where is your black soil, if I should call it that? Where's the black soil? Go ahead, Ainsworth.
The black soil's at the top.
It's at the top. That's your top soil there. The one that will come down first. Okay? First from the go ahead.
In the beginning, the water was really murky, where you couldn't really see through it at all.
Yes.
But now all the sediments settled, so it's more clear than before.
Yes, and that's a very good example. Even when the water may look quite clear, there still can be quite a lot of sediments, a lot of siltation occurring in that water. And you may see that when you have things starting to move around in the water, you see how quickly that water is disturbed, and you see the sediments there. Okay? So even when it looks quite clear, we know that all water bodies will have sediments. They will have some silt, but then we don't want extra to go in there. We don't want too much erosion to happen to continue accumulating more sediments, more siltation in our water bodies. Okay? Thank you for your input. Thank you for listening. And I'll give you a clap today for your input. I think I heard from everyone today.